Our beautiful planet, as we know it, is being destroyed by the burning of non-renewable fuel sources found in crude oil. These fossil fuels are releasing greenhouse gases, causing huge amounts of pollution and the temperature of the planet to rise. One proven way around this is the use of solar energy, which is both reliable and environmentally friendly. However, storing energy easily and effectively is the holy grail of the renewables industry. Solar thermal panels mounted on the roof of a house create hot water, which is normally stored in a large tank in your home. When water is needed for a shower, the water is tapped off directly. While storing energy as water is great, it is also large and bulky to store, so storing enough energy can be problematic. Another way around this is to create a high energy density battery. The energy can be stored during the day as the battery is charged, and when hot water is required, cold water is pumped to the battery, instantly heated and sent to your shower. Your hot water tank could be reduced to half the size but with the same capacity. Paraffin wax is a phase change material that when melted into liquid form, it absorbs a huge amount of energy without increasing in temperature, and in comparison to water, can store twice as much energy per unit volume. So how do we get that energy out? Well, if you surround a conductive pipe with liquid paraffin and flow cold water through the pipe, the energy from the paraffin transfers to the water when the paraffin solidifies on the pipe, releasing huge amounts of energy and heating the cold water. One problem, however, as the paraffin solidifies, it also insulates the pipe, preventing heat transfer. A test rig was built to determine how suitable paraffin would be for thermal storage, whilst being representative of a domestic dwelling. The original design used a copper pipe heat exchanger. However, it was found that the paraffin quickly solidified on the pipe, trapping heat and preventing heat transfer. Transfer fins were installed to increase the surface area, which at first, due to build-up of paraffin between the fin and the pipe, had a negative effect. The number of fins was increased to give a 20mm gap between each fin to allow the paraffin to solidify in layers. The fin gap was decreased to 10mm, which produced over 1 litre of hot water at a rate equivalent to that of a shower at 8 litres per minute. The difference between the original design and the high surface area heat exchanger design was an increase in efficiency of 150%. Following on from lab testing, a final product was specified. A unique heat exchanger design was used, which was adapted from existing technology, but would allow 2 separate water loops to transfer heat from paraffin cavities without any mixing of the 3 mediums. The simple plate design created a very intricate and unique flow route, whilst maintaining a very low cost in comparison to other heat exchanger designs. The heat exchanger is fully contained and insulated, allowing easy installation into the family home. The final product can store over 2 days' worth of hot water for a family, but in a much more space-efficient manner and in an environmentally friendly way. Further work is required to create a more efficient design. However, it has brought us another step closer to becoming less reliant on fossil fuels and another step closer to saving our planet.